Now that we finished talking about exponential functions, we need to talk about their inverses, which are called logarithmic functions. I'll let you read through the stuff in the blue box. What I want to draw your attention to is right here. This is how you convert between exponential notation and logarithmic notation. It's very, very, very important that you understand this. X equals a to the y is the same thing as y equals log base a of x. So if I have something like 2 equals x to the b, and I wanted to write that in logarithmic form, what I always do is start with my base, because the base in the exponential form and the base in the logarithmic form are the same. So I would say log base x of, go to the other side, 2 equals b. The other thing that I like to remember is the log is always equal to the exponent. The log equals the exponent. So if we were to graph these, let's look at this graph first. This is the equation y equals e to the x. This is what we learned in the last section. The logarithmic function is its inverse, which means it's reflected over the line y equals x. So this would be the equation y equals log base, I'm not really sure what the base is in this case, so we'll just call it a, log base a of x. That's the equation of this line. I guess I could say the same thing here. This could be just a, since we don't know what the base is in this particular function. If you were to have an a, or a base that is between 0 and 1, then your graph is going to be reflected over the y-axis. Remember, if we took this graph and reflected over the y-axis, we would get this one. Well, your inverse of that, the logarithmic function, is reflected over this line. That's where this red graph comes from. So what you're doing is taking this purple or pink line and reflecting it over this dashed line to get the red one. This one is the logarithmic function. This one is the exponential function. So what we want to do is sketch each of these. And of course I've already included the graphs for us, but let's see how they work. We have log base 3 of x plus 3 plus 2. Well, if we just had log base 3 of x, what would that look like? Log base 3 of x would look something very similar to this one. Okay, so keep that in mind as we go to this page. Log base 3 of x is this one right here. So what happens when we add 3 on the inside? It's going to take this and shift it 3 units this way. So what's going to happen when we add 2 to it? It's going to shift it 2 units up. So we take this graph, shift it 3 left and 2 up to get the equation of the function f of x. So how about b? This one's a little bit tricky. So we have log base 2 of negative x plus 2. Well, what does this one look like? Log base 2 of x. That would be this purple one right here. This is log base 2 of x. So what happens if we were to do log base 2 of negative x? What would that do? It would take this graph and reflect it over the y-axis. So it would look something like that. Okay, so what happens if we have this plus 2 in here? Now be careful. This is the same thing as log base 2 of negative x minus 2. So this negative made it reflect over the y-axis. but since we have minus 2 inside the function, it's going to take this graph and shift it 2 places to the right. That was a little bit tricky. How about the next one? Log base 1/2 of x and all that plus 1. So this purple pink line, this is your log base 1/2 of x. That's this one. So what would adding 1 to this function do? It would simply shift it up 1 unit. So let's evaluate these expressions. To do that, you need to know how to switch between logarithmic and exponential form. This is 4 to something equals 64. 4 to something equals 64. Well, remember the rules for exponents? 4 to the x equals 64 is the same thing as 4 to the what power? 4 to the third power? So that means x must be 3. So log base 4 of 64 is equal to 3. That's what that means. So how about b? For b, we have a 1/5 to something equals 5. Well, what do you raise 1/5 to get 5? 1/5 to the -1 is equal to 5, right? So x must be equal to -1. So in this one, log base 1/5 of 5 is -1. How about c? 7 to something is the square root of 7. Well, 7 to something is equal to 7 to the 1/2. Remember, the 1/2 is the same as the square root. That means x is equal to 1/2. How about d? We have 11 to something equals 1. The only way you can get 1 there is if x is equal to 0, because anything to the 0 power is 1. So how about e? 36 to something equals 6. How can we write 36 with a 6 as the base? That will be 6 squared equals 6 to the 1. That means 2x must be equal to 1. Divide by 2, so x is equal to 1/2. 36 to the 1/2 equals 6. That's what that means. Okay, finally f. I put that the wrong way. 10 to the something equals 1 over 1,000. So 10 to the x is equal to 1 over 10 cubed, because 10 cubed is 1,000. 10 to the x is equal to 10 to the -3, which means x must be equal to -3. Use the elementary properties of logarithms to solve the following equations. What we want to do is just switch from logarithmic to exponential, or from exponential to logarithmic, and then see if we can solve it from there. So here we have 2 to the -5 equals x over 8. What is 2 to the -5th power? That would be 1 over 32, right? If you multiply both sides by 8, you get x is equal to 8 over 32, or x is equal to 1/4. We should check that to make sure it works. Okay, how about b? We have 4 to the log base 2x of 6 is equal to 6. Well, this one is written in exponential form. So what I want to do is rewrite it in logarithmic form. So we have log base 4 of 6 is equal to log base 2x of 6. Well, this is the same thing as log base 2 squared of 6, right? Since the argument, by the way, this is called the argument. Since the arguments are the same, then the bases must be the same. So 2 squared is equal to 2x. 4 equals 2x, which means x must be 2. And finally c. We have 3 to the 7th equals 9 to the x. 3 to the 7th equals 9 to the x. 3 to the 7th is equal to 3 squared, right? So 7 must be equal to 2x, which means x must be equal to 7/2. Common and natural logarithms. I can't talk anymore. If you don't see a base here, it's understood to be a 10. That's what it would look like, log of x. So there's an invisible 10 right here. If you have a log base e, that's called a natural logarithm, and it's usually written with an ln. So ln of x means log base e of x. So let's look at this a one right here. Natural log of the 4th root of e. That's the same thing as the natural log of e to the 1/4 power. Really, all you have to do is plug that straight into your calculator. Natural log of e to the 1/4. So second ln 1 divided by 4 equals. And guess what you get? You get 1/4. Now why would you get that? Because the natural log of e is just 1, which leaves you with the 1/4. So what about this one? This is 10 to something equals 10,000. 10 to something equals 10,000. Well, 10 to something equals 10 to the 4th power, which means x is equal to 4. Of course, you can plug that straight into your calculator also. Log of 10,000, and you should get 4. So how about the next one? Natural log of 5.92. That one we can't calculate by hand. Well, we could, but that would take forever. So natural log of 5.92 in the calculator is approximately 1.7783. I'll put this here so we'll know that's an approximation. It's approximately this number. So how about the log of 9.7? This one would be approximately 0.9868.